This video, let us try to have a look at the transform domain analysis of real-time systems. What's that mean now? It means I'm trying to have a look at the transfer function and the impulse response of linear time invariant systems. So what does that mean now? Let's try to quickly understand the basics and then solve some examples. We all know that I can indicate any system, in fact discrete time system, with impulse response h of n. So h of n characterizes the system. We have an input which is x of n, and there is also an output y of n. The previous classes we have seen that y of n is given by the convolution of h of n convolved with, this is convolution signal, x of n. So now what I do is I take the z transform of this entire equation. So y of n will have its z transform as y of z. This is equal to, we have seen the property of z transforms. It is called the convolution property. That means the convolution operation in time domain gets converted as multiplication in frequency domain. So h of n will now become h of z. Convolution will now become just a multiplication. X of n will be x of z. So y of z is equal to h of z into x of z. So these represent the z transform of individual terms. So it means that I can rearrange this as h of z is equal to y of z divided by x of z. Now this is called the transfer function of the system. Very simple to understand. Transfer function of the system. And if I take its inverse z transform, it is going to get me h of n. So the point is, if h of z is given to me, I can find the impulse response of the system very easily using this particular type of analysis. Let's try to see some examples in the next video.